Hey everybody, this is Larry. It's March 12th. Uh, Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem. What was I to March? Check if a string contains all binary codes of length k or size k. Okay, cool. So I do these live, so if it's a little bit slow, just fast forward or whatever you need to do. Don't feel like you need it to be stuck on anything. But okay. K is less than or equal to 20. So, I don't know if there's anything tricky about it. Basically, the idea that I would do is just have a sliding window and just keep track of all possible strings and then check whether it contains all of them. Of a string, a binary code of length k will have 2 to the k number of possible strings. I don't know if there's any way to do it other than checking all of them. I don't think so. I could be wrong. So basically, we're just going to set up a set or something like that, or even having an array and then just going through it and then using a. This is probably a good practice of the sliding window where you look at 2 characters at a time and then it's just shift and add and mod, I guess. Yeah. And when I said k is less than 20, you know that this can be at most a million copy, which is 2 to the 20. A million and change, obviously. But yeah, and then that's gonna be good enough. Okay, cool. Let's start coding. Though my Chrome is acting up a little bit. I don't know if this happens to anyone else, but it feels like Chrome sometimes once in a while like does something expensive or something. But yeah. Okay. Okay. I don't know why I'm having trouble scrolling, but okay. And then it scrolls from me clicking on it. Okay, I think now it's good. Okay, so if the length of s is less than 2 to the k, okay, let's just set n is equal to length of s, max. Let's just say m is equal to 2 to the power of k. And I know that if you're good at Python or even just good at programming, you might do the left shift thing. I probably would in my free time, but I'm trying to be a little bit more readable because normally I would probably just write this. But some people find it especially for beginners, it may find it confusing. But yeah, if m is greater than n, then we return false because we just don't have enough characters. It's binary, right? Okay, yeah. Otherwise, oh yeah. Otherwise, we said let's just have an array, or just have a scene of force times m. Basically, we want one thing for each element of the 2 to the k, and then that's pretty much it. Maybe I would say so. Let's have a current number for index in range sub n. And I would also say this is a good sliding window practice, even though it's not explicitly that, but it's just about thinking about the boundaries and stuff like that. I would also say that, what was I going to say? Oh yeah, this also is very similar to, was it Robin Corp? Robin? No, Robin Corp, the string matching algorithm, except for in this case, you mod it by 2 to the k. So yeah, so basically we have current, we added, actually we shift first, as we said, so we times it by 2, and then we added by s of index, the int version of it, and then we mod it by m in this case, because that's the size of the thing. And then now we go scene of current is equal to true, and then now at the very end we just have to check that this all true, right? So we return all of scene dot. Can I just do that? Or do I have to do? I don't. Yeah. So not all of this, then that means it's. Oh yeah. If all of them are true, then this is good, right? I don't know. Do I have to? Okay, yeah, that looks good. Yeah, because every element is true, then we're good. Now we have to kind of put in the test case more. Hmm. I am okay. Just pretend this is a montage, or skip forward a little bit. There's so many test cases, but it's good. Then we have more confidence, but it just takes some time. They need to set up the one test case thing in here as well, I guess. Oh, what? Oh, I just missed a semi. Pending, pending, pending. Ooh, why is this? I returned true, but it's false. 0, 1, 1. Oh, it doesn't have 0, 0. Oh, I did mess up. I actually thought about this while I was doing it, but then I forgot. But basically, we want to. That's why I brought up sliding windows. Is that we have to make sure that we have all length of this before we check it out. Is it of k or k minus 1? So if the index is k, then yeah, so this is k minus 1. Okay, this is why we tested though, because that would have been a silly mistake. Because I actually, and it really does feel like a silly mistake because I was thinking about it, and then as I was talking about it, I just forgot about implementing it. That's why I've talked about sliding windows, is because I was going to have a segue about talking about this, but I messed up. Sometimes you get silly. Okay, but that's all I have for this problem. Pretty much it's linear because we look at each index once. We assume this is all 1 and this is all 1. In terms of space, we only use it for O of m, where m is 2 to the k. So yeah, and yeah, you can also maybe use a set for different performance profile, but it's roughly the same. So I think this is okay. Cool. Yeah, that's all I have. Let me know what you think. Hit the like button, hit the subscribe button. Have a great day. Stay good, stay well, stay healthy, and to good mental health. I'll see you later. Bye bye.